Hello, I'm John Tonner, the Executive Director of AMTA, and today I'm interviewing a new Hall of Fame inductee in the Chats with Pioneers series, Erik Roesink. Erik is with NX Filtration and was a founder of X-Flow and developer of the Ziga hollow fiber membrane.
So thank you, John. My name is Erik Roesink, and I'd like to start in 1970, though I was born in 1952. In that time you go to the university, so I started at the University of Twente, very important university in my life. And already early in the 70s I came in contact with Professor Feijen, where I did a subject on studying blood compatibility of polyethylene grafted surfaces, make it very technical. That was in fact already the first contact with membranes, so I decided to do my master's in membranes. And then I met Professor Smolders, which I consider to be, call him the godfather of the membrane, certainly in Europe and also worldwide. He played a very important role, certainly with respect to what we call membrane formation. I think he did a great job with his students in discovering and in learning about phase separation, non-solvent phase inversion. And I did a job there in, that was in 74, 75, and in that time John Cadot already brought his thin film composite interfacial polymerization membranes to the market. And we were an ambitious group in the Netherlands, and so we were looking for alternatives. So I was sulfonating block copolymers, styrene, isoprene, with all kind of chemicals. It was a beautiful journey. I learned about electron microscope, about membranes, and got new friends. The membranes were shit. But at least the passion for membranes started in that time. But it was also the time, if you allow me to go on, it was also the time that we had the so-called chemical crisis. So there was not that many work for chemists. I was a chemist, chemical technology. And since I needed some financial assistance to continue my study, I decided to go into teaching. And I taught on a high school nearby the university mathematics, though I was a chemist. I did it several years, but then I thought, hey, becoming a teacher for another 40, 50 years, that's not my life. And then I came across the same Professor Smolders. We met each other on whatever occasion. He said, hey, listen, Erik, so two of your colleagues are also considering to start a company. You contact them. And we also have opened a PhD position, which could then be also contribute to the company. And the company was X-Flow, to make it sure. The two guys were Dick Koenen and Luther Bruns, so the co-founders. And I started in 85, in March 85, in developing hollow fiber membranes. The idea was to develop hydrophilic microfiltration membranes. We had in that time already Memcor, Memtech, with its polypropylene membranes, which would be hydrophilic. The idea was to come up with a product which could be used as pre-treatment RO. And so I started to work with some polymers and finally ended with polyether sulfone. And then to make it hydrophilic, I already learned via Israel Cabasso, just a name, but it pops up spontaneously talking with you. He did some work with PVP, and I used that idea. And I managed with some tricks, etc., to make a polymeric blend. Polymeric blend is quite special in the polymeric world. And with that polymeric blend solution, I could make perfectly microfiltration membranes. And that microfiltration membranes initially, as I said, were meant to be used for reverse osmosis, pre-treatment RO, because Dick Koenen came from the reverse osmosis world, so he saw potential for that. But the early days when we started X-Flow, so I did my PhD in 85 till 89, and then I jumped into my career as R&D manager with X-Flow. So we grabbed some money, we collected some money so we could build our first spinning line. We learned about potting, making modules, etc. And pre-treatment with microfiltration membranes in the RO world was difficult. We did a small project, I remember, on the Rainbow Warrior. The Rainbow Warrior, as you might remember, was the flagship of Greenpeace. So we also were double proud that we were on that ship. I think we even used that in our presentations. But we did something on marine ships in Denmark, with I remember, but not the big thing in pre-treatment RO. But we were successful in wine. So we produced perfectly hydrophilic, low fouling wine membranes. So I could start, that was my job as well, I was busy, though I was an R&D guy, I was an outgoing R&D guy, so I was also allowed to speak with customers. So I worked together with a German company called Seitz Filterwerke. And there we started the wine business. Meanwhile, I started also the development of beer filtration membranes. That took a bit more time to make that successful in the market. That was end 90s, early 2000 when we had the breakthrough. We worked together with the company Heineken, Dutch brewing company, so we worked closely together to fine-tune that membrane towards an industrial product, which it still is. It was also mentioned today in the nomination award. So it's still the only used membrane worldwide in filtering beer, successful. But back to the early 90s, and I recall that also in my short speech this afternoon. We had Milwaukee. For those who are longer in the business, it's a well-known activity. Then close to 90 people, I think, passed away due to cryptosporidium. In that time, water treatment was a bit early stage. And the good news there is that upon what happened in Milwaukee, legislation became active. You had the surface water treatment rule in the United States. In the UK, we had legislation. And in the Netherlands, I came across a company called PWN. PWN is a Dutch drinking water utility in the northern part of the country, close to the sea. But they take the water from the Lake IJsselmeer. The Lake IJsselmeer is fed by water from the Rhine, River Rhine, coming from Germany. There was some salinity due to the mines in France. There was already micropollutants, so the first concerns about bentazone and pesticides, insecticides, and whatever was there was already there. And they decided to use at least reverse osmosis in their treatment systems. In that time, the thin film composites were popular compared to the cellulose acetate membranes, as you also know here. But cellulose acetate membranes, though their low fouling properties are very nice and well recognized, the retention with thin film composite for micropollutants was higher. So we need something to protect the RO in their operation. And then PWN selected finally between Memcor, Aquasurs, Stork, X-Flow. So we were selected because of our new concept. Our concept was hollow fiber ultrafiltration, which was a further development from our microfiltration development. And we also decided at that time, and I think that was a very important decision we made within X-Flow, that we decided to come up with a standard 8-inch concept. So not as we see nowadays, everybody has his own whatever device, but we thought, let's open the door for ultrafiltration, large scale, then we should follow the RO world, which their standard 8-inch concept in pressure vessels. We come to that. And so our element fit into a standard pressure vessel, and then we had to do a lot of work with the membranes, with the element, and then also with the pressure vessels. That's the time I met one guy called Doc Eisberg. He visited once our company, because we know also some older people from the membrane world. And then we had to change the ports, the permeate ports, the feed ports. The side port was very attractive in our way because our volume streams were much higher than we were used in the RO world. And so we introduced the so-called XICA concept. I'm still proud to be, say, the guy who brought that to the market. Of course, not alone. It was in the time I worked together with De Koenen and Luther Bruns, some other guys. And we piloted that in Heemskerk, in PWN. And then we were awarded for the first, it was, I think, 15 or 20 MGD from the top of my head. So sizable, 3,000 cubic meter per hour. And that became the, let's call it the holy grail. I mean, we were at that time at X-Flow, we were a bit struggling with, okay, are we profitable or not? So from the mid-90s, where we were taken over by Norit, that was an activated carbon company, it was on the stock market, and they had this activated carbon for their water treatment processes, and they were in need also for innovation, new products, in order to please their investors. And so we were taken over. It was a good match. And in that time, 97, so we became profitable. I became the managing director The other two guys stepped out. And yes, I told you, Heemskerk was very important because then we could demonstrate the world that Sika was not only a nice idea, but it worked. So people from all over the world came to the Netherlands to visit Heemskerk. And then based upon that in the UK, as I told you, there's a lot of surface water for water treatment required. So also there the threat of cryptosporidium. And then also there several installations were installed using our Sika technology. Clay Lane, Three Valleys was a very important one in London and several other ones as well. People from Israel came in, from Mekarot, for example, just to pop up a name. But also from the US. We had the guy, I spoke today, by coincidence, Scott Freeman. And also Scott Freeman from the Black and Veatch that time here in the US. They traveled to the Netherlands to see the technology, and okay, finally, and still operating installation here in the US is Columbian Heights in Minneapolis, where drinking water is produced with ultrafiltration membranes, and also they're using the so-called Sika concept. The biggest commercial success, however, was in the Middle East. You talked about the Middle East, John. That was in Sulabia, Kuwait. A water reuse installation, pre-treatment RO. And also there, I think it was about 10,000 elements. So it was 10 times bigger, even more, 15 times bigger than Heemskerk. And it was already a sizable one. So yeah, that is the story for me, at least directing and a little bit in the direction we discussed it today. And meanwhile, we kept on producing hollow fiber membranes for wine, hollow fiber membranes for beer. So I think it was also expressed today in the presentation. If you talk about my membranes, it's about water, wine, and beer. All the three nice liquids you can enjoy and you can make money with, and that's a simple summary. Yeah. Big driver was standardization, and we, of course, we know about reverse osmosis, how there, say the elements, spiral wound elements, are pushed in positioned in a pressure vessel. Also, their spiral wound elements from ultrafiltration were already done, and that inspired us to go to the pressure vessel concept. But then indeed, then you need to make a membrane element which fits in a pressure vessel. Okay, then you take your 8-inch concept, and then you are entering issues with respect to, okay, if you put 4 in series, we decided initially for a 40-inch element. Later we switched to 60-inch element, but we started with a 40-inch element. And then if you put them in series, you may have to make sure that the feed, which is transported to one element, to the next element, to the next element, you are in balance. So your pressure drop over the length, which is a different level as in RO, it's much lower, so much more sensitive for pressure drops. So that was one thing we should overcome. And therefore we, as you mentioned, we introduced the so-called bypass channels. Initially it was a very clumsy thing with some PVC pipes put in the element. And step by step, we worked very closely together with a company called GB Ventures. That guy came also from the water industry. He was a brilliant designer. So we made a very nice design, which was also shown today on the presentation. But also, we could do backwashing, which is of course not applicable in reverse osmosis applications. So backwashing was interesting because we didn't want to go with high crossflow velocities in the vessels, because high crossflow velocities would mean high energy consumption. We want to stay competitive. The operational cost should be as low as possible. So we use this bypass tubes in order to have a stable transmembrane pressure over the length of the vessel, and in order to backwash with even higher flow is our operational flux. For example, if we run a Sika concept at an operational flux of 100, and sorry, but I'm thinking in LMH, then we should do the back flushing in double or 3 times the operational flux, say 250 LMH. And that's a lot of water you have to transport in a short time. And that's why we adapted this spiral wound element in a hollow fiber element with this so-called bypass tube. And we increased the bypass or the permeate port in order to overcome pressure drops during permeate production and backflushing. And also that also that time we worked with coat line in order to get these ports, these feed ports, larger typically than you need that in the so-called reverse osmosis. And that was typically based on the flows we had to handle compared to reverse osmosis. Yeah, we had higher recovery. So the ultrafiltration process using Siga, which is also possible with actual crossflow or dead end technology, is could be 90-95% even. I think Heemskerk was running on 95% recovery. Okay, John, thank you for the question. So it's about what were the challenges with respect to fiber breakages and potting and those kind of issues. And I think the most important was, in fact, the dimension of the fiber. Initially, when we started the company, we were working with 1.5 millimeter fibers. It was obviously in a kind of a crossflow mode, an ideal diameter to overcome pressure drop to be in a good range. But we wanted to have as much as possible membrane area in this element. And as you know, then you should make the diameter smaller, play with the wall thickness. So in fact, to make it short, we have to find the ideal combination of inner diameter and wall thickness, because that dictates the membrane area, but it dictates also your pressure drop over your module, and it dictates also the plugging sensitivity, and it dictates also how sensitive your membrane fiber is for breakage. So you should make a robust fiber, but find the ideal combination between, again, internal diameter, wall thickness, porosity, etc. And I think that cost a little bit of fine-tuning, though we were relatively fast to the point that we decided that the inner diameter should be roughly 0.8 millimeter, wall thickness should be 200 microns, and then you can play a little bit with that depending on your wall thickness or your wall porosity. The lower the porosity, the more membrane material, the more strength you get in your fiber, but it also adds up to cost. So that was an optimization thing. I know exactly, John. Sorry, your question is on whether we were inspired by the Permacep concept as well. And we had a look on it, but as you also perhaps know yourself, it's a completely different concept, different membrane. So it's a melt spun membrane. It's an out-to-in configuration. It's another configuration of your membranes. So the potting is different. So I cannot recall, say, distinct inspiration factors from that, despite that it's in a horizontal configuration in a pressure vessel. But we adapted that towards what is the Siga concept now. The question is whether how we acquired Stork. In the time we were in Noord-Ixlo, we saw that there was also another company in the Netherlands. That was Stork Friesland. Stork Friesland was producing so-called tubular membranes. And there was a guy, Arie Zwijnenburg, who also was already thinking about so-called nanofiltration membranes, hollow fiber nanofiltration membranes. And we were interested in both technologies. The tubular membranes would be perfectly complementary to the hollow fiber products, because then you could work with higher solid loads. Stork Friesland, for example, already had their first MBR technology based on the side stream concept. That was attractive, and that later came within Norit a very attractive product market combination. And the hollow fiber nanofiltration was based on a concept called thin film composite interfacial polymerization. So the guys from Stork tried to make a layer inside of the membrane based on interfacial polymerization. That seems to me a very attractive method, but we never managed to get that to a commercial product. So on lab scale it worked perfectly, but we never could make that in the time from Noord-Ixlo into a workable product, so we stopped that product. But that was my first time I was learning about the ideas of hollow fiber nanofiltration. By acquiring Stork, and when Pentair took over in 2011, 2013 officially I left Pentair. I was then already appointed as a part-time professor at the University of Twente. So what I mentioned already, the University of Twente was very important in my life. First you are a student, then you are a PhD guy, and then finally you are a professor. So I did all the three things in a university. And I went to the university as a professor, and because I was also without a job, because I was not paid for my professorship, I had to make up my mind how to further how to further work. I was 60, and I mentioned also today in my presentation that in 2013 my oldest grandson, that time the first one was born. And together that inspired me to come up with membranes who could deal with PFAS, insecticides, say the so-called micropollutants. And then in my back perhaps there is something of nanofiltration, but that's also perhaps driven by the fact that if you need to retain organic compounds with a molecular weight of 3, 4, 500, you have to go to the nanofiltration separation characteristics. So, and in that time, I worked together with Joris de Groot, which I want to mention very explicitly here. Joris de Groot was my co-worker. I know him also already from my Pentair Nordic time. And so we played with our support material. We developed our so-called layer technology. So we adapted a so-called layer by layer concept. Layer by layer was already done by a German scientist, which I cannot recall the name that quickly, but it was also used for making very stable coatings for cars or for other applications. And the charming thing here, very charming, was that it was using very regular polyelectrolytes, water-soluble polyelectrolytes. So we also were fascinated by the availability of the materials. The costs were relatively attractive, and it was water-based. And upon complexation of polyanions and polycations, negatively, positively charged materials, you get very stable, thin layers. That stable that you can rinse with activated chlorine, high pH, low pH. And so on lab scale, we already were quickly to a certain concept product, where you could retain all kind of organics. The tracer we used were so-called magnesium sulfate, which is an important tracer in a nanofiltration product development. So, and then, in 2 years, we had something in hand. 2015, it became serious. And then, I came in contact with an old colleague, Bernard ten Doeschot. He was heading and he was owning an investment company. And I mentioned that on purpose. And I was there more to ask him for assistance in how to develop a business case, a business plan, and how can you raise funds, etc. Because I'm a businessman, but I'm merely, with my technical sales background, an entrepreneur. And we were chatting 2 times, 3 times, and he said, what are you doing then? And I'm explaining that this product could be really a breakthrough in the water market, low energy consumption, low chemical consumption, and a high retention for all the things you don't want to find in your drinking water. So then we decided to do it once more time together. So in 2016, Annex Filtration was founded. And we started with an empty hall and good funding. And so we installed the equipment. And let me highlight that the so-called layer by layer coating technology, if you are aware and you are familiar with the technology, you see a lot of groups worldwide playing with that technology in lab scale format. Nice articles, nice papers. But to bring a lab scale layer by layer technology to production facility and making 10,000 modules, and we are planning to make 100,000 modules per year, that's another ball game. And I'm extremely proud that we managed with the team around me, I mentioned yours already, but some other persons as well, to build production equipment with that. And we did it also very clever, in my perspective, because of course you can protect your knowledge, that's important, your IP, if you have a new company. So we have several patents filed, and a patent filing, you only do it when you can protect it. But a lot of this knowledge you need to scale it up is proprietary. You cannot file it because then you tell what you do. So we selected partners for a small piece of the whole production line, typically local or not so far away partners, designed the spinning lines, the rinsing lines, and whatever, dope equipment lines. And we managed that never, say, one guy saw the whole production line. So that's the level of production we brought into our production. We also, when we started the company in 2016, the guys from the person of the first hour get a small package of shares in the company. So they get also a little bit of connection, so extra motivation to stay in the company, and they're still there. And based on that, we saw the success in the market already in 2017, 2018, 2019, and then 2020 started. In 2020, if I may make a small side sprung, it was the last time I was in the United States. I visited Oceanside. For those who know, that's the place where we find a company called Hydronautics. Hydronautics was, in that time, also next to their reverse osmosis products, also marketing so-called ultrafiltration products. That products that time were produced by a company called Inge. The company Inge was taken over by DuPont, and suddenly Hydronautics and DuPont were competition. And so Hydronautics was in need for another supplier. I picked that up in the market and I flew into Oceanside and we took over the business. It was important because if you start a company with a new technology, of course, sales is nice, but it's also not that easy. And with ultrafiltration, it's more accepted in the market. You can do more faster sales and get a kind of a bread and butter business in a company. And that's what we are still using ultrafiltration for. Also, for example, to do cross-selling. If you bring your ultrafiltration products to the market, which is a well accepted working tool for a lot of technology companies, you can also then take the opportunity to learn them about hollow fiber nanofiltration. That's what we're doing still. So in 20, took over the Hydronautics business, and we were making up our mind, hey, how can we grow faster? And why did we want to grow faster? Because we saw the product is okay. We saw the market is there. Hey, you all know that we have what we call a water crisis. And this morning I mentioned water transition. And the water crisis, to mention that again, is dealing with water scarcity, but also with water pollution. And that's driven by what we could call the climate change, higher temperatures. We see extreme dry periods, even in the Netherlands, and say worldwide, that's a thing. That means also that groundwater is going farther and farther away. And that's also what we heard Tuesday on your planetary keynote lecture. So we are forced, like in the energy transition, to go to other sources. In the energy transition, you need to go to solar, PV, to wind. And in the water industry, there's only one water. So you have to step away from groundwater. You have to focus fully on wastewater and on river water. That's also exactly what was explained by our keynote author last Tuesday. And that membranes can do that. They can very efficiently filter effluent, clean effluent, river water. We have proven that worldwide already in an early stage. So then you need growth capital. Because if you believe in your product, you believe in the market which is there, then you should grow and not wait till you have a small turnover, then you should do the right thing. So I'm proud on a lot of my technical innovations, which we are highlighted in this interview. But I'm also very proud that I found the right partner to have the vision to take care for enough capital to grow if you believe in your product. And that's what we did. So we went public, raised capital, growth capital of 150 million. And with that, we were growing faster. We were using the majority of that money for building a new factory. The new factory is almost ready for starting. I told you we have now a capacity of 10,000 modules per year, which is really a sizable production for a young company. But then we go to the next step. And that is the process we are in. And though when I was 10 years ago, my grandson was born, I was having doubt what to do. And suddenly you're an entrepreneur with a beautiful technology in a fast-growing company.
I'm to congratulate Erik for the achievements that he made with his colleagues at Norrit and continues to make with his colleagues at NX Filtration. AMTA would also like to thank Erik for taking the time to participate in this interview while he attended the 2024 Membrane Technology Conference to be inducted into the AMTA Hall of Fame. Don't forget to subscribe if you want more membrane-related content. And hit like. We'd really appreciate it. Thank you.